we are going to study about the second control system component, stepper motor. So what is a stepper motor? Stepper motor is an electromechanical device So it is also an electromechanical device. It is mechanical input, and in the output we are getting an electrical signal. It is also a digital device because it is working on the pulses. Okay, that is digital device. If you represent a digital device, it will look like that. It is either at one time it is 0, then at one time it will be 1. So the output will be like this, digital output. So it is an electromechanical digital device. Now the stepper motor, it actuates means it gives an output. So stepper motor, it is giving an output in the form of train of step movements. That is, train means a continuation of step movements in response to train of input pulses. That is, the input is this in the form of pulses to the stepper motor, and in response to this input pulses, it is giving the output in the form of step movements. That is, the rotor of the motor, it is moving stepwise. Okay, so this rotor, it is going to move one step at each input pulse. That is why this stepper motor, it is a digital device, because the input is also a digital signal and output is also a digital signal. That means the stepper motor, its output, what is the output of the stepper motor? The shaft, the displacement of this shaft. So shaft angular displacement, and this output, it is completely determined by the number of input pulses. So the output of the stepper motor, it is the angular displacement of the shaft, and this angular displacement, it is determined by the number of input pulses. Now this angular displacement of the shaft, it can be linear or it can be rotational, and also it can be either in the clockwise direction or it can be in anti-clockwise direction. That is the movement of the shaft. It can be angular or linear, and also it can be either in the clockwise or the anti-clockwise direction. Now each input pulse, it will initiate a one step movement. That is, the one input pulse, it will give one step movement. Second input pulse, it will give second step movement. So in response to the input pulse, we are getting an output displacement. So the movement of the total movement of the stepper motor, it will consist of many discrete step movements. So one rotation of the stepper motor, it will be equal to many short or many small step movements. Okay. So each revolution means one complete movement of the stepper motor. Suppose it's starting from a point and it is completing the full circle, so it is one revolution of the stepper motor. So each revolution of the stepper motor, now to understand this, take an example that the suppose the step size of a stepper motor. So we are taking an example where the step size of a stepper motor is in between 1.5 degrees to 30 degrees. Now if the Now, the stepper motor is having the step size between the range 1.5 to 30 degrees, and we are taking the example where the motor is having the step size as 5 degrees. Okay, we have taken the step size as 5 degrees. Now, if the input to the stepper motor it is 5 clock pulses, then the complete rotation of the motor will be 5 into the 5 clock pulses. So 5 degrees into 5 clock pulses. So it will be the motor will move by 25 degrees. So the angle of rotation, it will be 25 degrees for a stepper motor with a step size of 5 degrees. So in this way, we will calculate that how much the stepper motor is moving. Now the direction of the movement, as we have said that it can be either clockwise or anti-clockwise. So this direction of the angular displacement, it is determined by the direction of the input pulse, that whether the input pulse is from high to low or it is from low to high. So according to that, the direction of the rotation of the shaft, it will be decided. Now let us study the types of stepper motors. Stepper motors are classified on the basis of their construction and their working. So according to that, there are three types of stepper motors. First is variable reluctance stepper motor. The second type is permanent magnet stepper motor, and third is and this classification is done depending upon the construction and performance of these motors. Now, in this video, we are going to study only this permanent magnet type stepper motor. Okay, because this motor is very important. So, we will study only this permanent magnet stepper motor. Now, let us see the construction for this permanent magnet stepper motor. Let's draw its diagram on the next page. We have this is the stator of the these are the rotors of the stepper motor. This is the stator having 4 poles. Now on each stator we are having a winding. This was the rotor and it is the stator. Now this is the permanent magnet stepper motor, and in this we are having the stator. There are 4 stator poles. There are 6 rotor poles. Okay, and the full step angle of this motor is 30 degrees. That is, for every input pulse, this rotor, it will move by an angle 30 degrees. Now let's see how it works. These stators, they are wounded with the windings, and each winding will be separately excited. Okay, that is, at one time this A winding will be excited, then at another time B will be winding, then C and D. No two windings, they will be excited. Means at the same time we are not exciting two windings, only one winding will be excited at a time. Okay, now these stator windings, they are wrapped in such a way that so these are the stator windings. They are wrapped in such a way that if we closed any of the winding switch, that is, we are exciting this A winding, then of the pole of this stator, it will become magnetically north. Okay, suppose we are exciting this A winding, then this pole will become north, or it is going to induce south pole in this rotor. Okay, so at this position, this north and south pole, they are going to attract each other, and this north pole will induce south pole in this rotor poles. Okay, so stator windings, they are wrapped in such a way that closure of any of the windings control switch, it causes that stator pole or this winding pole to become magnetically north. Now, if the 6-pole rotor, it is now if this 6 poles rotor, it is permanently magnetized, then so if this 6-pole rotor, it is permanently magnetized and only a single stator winding, as I have said earlier, it is excited one time, then the nearest south pole of the rotor, it will align with the excited stator pole. As I have said that, let's see the diagram. In the diagram, this is, suppose we have excited the A stator winding, and this stator pole, it has become magnetically north, and this north pole, it will attract the nearest south pole so that they will be aligned in a single line. So in this way, the movement of, or the, here we are giving this stator winding as the input pulses. So these input pulses, they are causing the angular displacement of the shaft, or the output of the motor, it is the angular displacement of the shaft, and this angular displacement will be in steps. That is, for first movement, it will move by a step angle of 30 degrees. So in this way, the permanent magnet stepper motors, they work. Now let's see that where these stepper motors, they can be used. As it is used as a control system component, so the first application of the stepper motor is in automatic control systems. Second, we can use them in computer peripheral systems. The other name for this peripheral is output. So we can use these stepper motor in the computer output systems. That means that they can be used as systems, output systems of the computer, such as printers, tape drives, capstan drives. So all the output systems of a computer, we can use there the stepper motors. Now they can be also used in process control systems, in paper drive mechanisms, in spacecrafts, watches, etc. So these are the uses of these stepper motors. That is, they are used in the automatic control systems, in process control systems. They are used in the computer peripheral systems like printers, tape drives, capstan drives. So in this video, we have studied about the second control system component, stepper motor, and we have seen that the stepper motor is a digital electromechanical device because it converts the input pulses, which are in the form of a digital signal, into a output, which is the angular displacement of the shaft. Then we studied the types of stepper motors, and we have seen that there are three types of stepper motors: variable reluctance stepper motor, permanent magnet stepper motor, and permanent magnet hybrid stepper motor. And out of these three, we have studied here in this video only one stepper motor, that is permanent magnet stepper motor, and its working we have also seen here. And then in the last, we have studied the applications of stepper motor. I hope this topic is clear to you. Thank you.